Welcome to the Deep Dive. We're here to plunge into complex topics and pull out the essential insights for you. Today we're looking at manufacturing, but maybe not like you've seen it before. We're stepping onto the factory floor of tomorrow. Just try to picture it. An incredibly intricate, precise operation. Every machine, every process, moving in perfect sync, driven by tech that feels, well, almost futuristic. But here's the really interesting part. Artificial intelligence, it's not just tweaking this picture, it's fundamentally reinventing it, pushing way beyond standard automation to something our source calls cognitive automation. So our deep dive today is all about that profound impact. AI and the future of manufacturing. We're basing this conversation on a really comprehensive white paper, The Impact of Artificial Intelligence on the Future of Manufacturing. It details how AI is moving from, small experiments right into the core of this huge sector. Our mission here is simple. Unpack the biggest insights from this paper, give you a shortcut to understanding the tech, the benefits, the challenges, and the new business models shaping these AI-driven factories. Okay, let's get into it.
From the very first design sketch to the final product delivery, AI is reshaping, maybe not so quietly anymore, every single corner of the factory floor.
Yeah, and what's truly fascinating, I think, is just the sheer scale of this change that's expected and how soon it might happen. This paper projects that as early as 2035, AI-driven factories could deliver, get this, 30% higher productivity, along with maybe 20% lower energy use and 15% fewer defects compared to even the best factories we have today. These aren't small adjustments, They're monumental shifts. They'll totally redefine what's possible in manufacturing.
Wow, okay. 30% higher productivity, 20% less energy, 15% fewer defects. Those numbers are almost hard to wrap your head around, right?
Okay.
But for us, for you listening, what does that actually look like on the factory floor? Can you give us some specific examples from the paper? How does AI actually achieve these gains in different parts of manufacturing?
Absolutely. Let's make it more concrete. Let's look at product design and simulation, for instance. The paper shows AI is, revolutionizing this through things like generative design and faster simulation. So imagine engineers just setting the constraints performance needed, materials, weight limits, cost targets. Instead of them manually sketching and tweaking, AI algorithms can generate thousands, literally thousands, of viable designs almost instantly. This means concept iteration happens maybe 2 to 3 times faster. They can explore options that would have taken ages before. And critically, it leads to maybe a 10 to 15% reduction in material weight. AI finds these incredibly optimized structures, plus those complex simulation cycles. Used to take days, now maybe minutes, because AI's surrogate models give quick, accurate performance predictions. Then you have quality and inspection. Precision there is absolutely critical, right? And AI is proving just unbeatable. AI-powered computer vision systems, for example, they scan products for defects way faster and more accurately than any human eye could. Combine that with anomaly detection on sensor data from machines. The paper claims these systems can achieve an incredible 99.9% defect capture rate. Think about that. Near perfect, basically stopping errors before they even happen. And it also means about a 40% reduction in the labor needed just for inspection tasks. It's about consistency, tireless accuracy. And it's really important to get this. It's not just about replacing people. It's about improving workforce and safety. AI really changes how humans and machines work together. Take augmented reality, AR assistance. They can overlay instructions right onto what an operator's looking at, step-by-step guidance. The paper says this can cut training time by 40%, much faster to get new people up to speed or train existing staff on new tasks. And there's also pose estimation AI. Uses cameras to watch worker posture. If it sees an unsafe position, it gives a gentle nudge, a prompt. This could cut musculoskeletal injuries by up to 30%. So you get safer workplaces, obviously, but also a documented 25% productivity boost for operators. They're just working more comfortably, more efficiently, less strain.
That's a brilliant example of that cognitive automation idea we mentioned. It's not just automating one thing. It's adding real intelligent prediction, making smarter decisions everywhere, and actually helping people do their jobs better. Clearly not just automation for its own sake. It's faster, safer, less waste, and empowering people too. So what are the core AI technologies making all this possible, the ones getting so sophisticated?
Exactly. These benefits aren't magic. They come from specific AI tech that's maturing fast. Let's quickly touch on a few key ones. First, reinforcement learning, or RL. The big deal with RL in manufacturing isn't just that it learns by trial and error, getting rewards. It's that it can figure out the best strategies in really complex, constantly changing situations. Think coordinating thousands of operations, optimizing energy, planning robot moves on the fly. It's like having a super smart conductor for the whole factory, always learning, always improving, finding efficiencies humans just wouldn't spot. The paper shows RL-driven scheduling, for example, can boost line utilization by maybe 8 to 12% over old methods. Then there are digital twins. These are basically live, virtual copies of physical things, a machine, a product line, maybe the whole factory, their main power. Predicting maintenance needs super accurately in simulating scenarios. Imagine testing different settings, new designs, even emergency procedures in the virtual world before touching anything real. This kind of foresight leads to amazing results like 30 to 50% fewer unplanned shutdowns. You know when something might fail before it breaks. And that also means 15 to 20% lower maintenance labor costs. Maintenance becomes proactive, targeted, not just reactive fixes. And lastly, let's talk about explainable AI, XAI. This tackles that common worry about AI being a black box, where you don't know why it made a decision. XAI is all about making the AI's reasoning transparent, and that's huge for building trust, especially on the factory floor where safety and control are everything. For engineers, for operators, XAI means they can check the AI's suggestions, understand the logic, and feel confident refining things. It's informed collaboration, not just blindly following the tech.
That's a really key point about XAI and trust. Makes perfect sense. It really drives home that these aren't just abstract concepts anymore. They're powerful tools, delivering measurable results, fundamentally changing how factories run. From self-tuning production lines to predicting failures, and now even understanding the why. It keeps coming back to that cognitive automation idea, doesn't it? Intelligence woven throughout the whole system.
Precisely. And to really show this in action, the paper has some great real-world examples. Take an automotive engine plant using AI for predictive maintenance. They use what's called a hybrid physics-ML digital twin on 12 critical CNC machines. So hybrid physics-ML twin. It combines the known laws of physics, how forces, heat, materials behave, with AI learning from loads of real operational data. This makes its predictions incredibly accurate, even for things it hasn't seen before. The result for this plant, a massive 42% drop in unplanned downtime. And that wasn't just fewer headaches. It translated to about $1.8 million in cost savings in just 18 months. Prevented costly failures, kept production running, plus the maintenance teams. Instead of just fighting fires, they could focus on proactive improvements, higher value stuff. Another really strong example is from aerospace, using generative design for wing brackets. These are critical parts where weight is everything. They used an AI design engine that explored over 10,000 different shapes and structures topologies. They managed an 18% weight reduction in these key parts. That directly meant a 12% saving on material costs, which really adds up in aerospace. And maybe even more impressive, the time needed to certify these new designs was cut from 9 months down to just 3. In an industry with super strict safety rules, speeding up that design to production cycle like that's a huge competitive edge.
Yeah, these aren't just theories anymore, are they? This stuff is happening right now. Real companies getting real, tangible results. It's powerful proof that investing in AI, when done strategically, is already paying off big time. So for companies thinking about this, what really makes the difference between a successful rollout and just another pilot project that fizzles out?
That's the key question, isn't it? And these aren't just lucky breaks. The paper suggests a clear pattern. Success comes from strategic, well-thought-out implementation. And when you zoom out, look at the bigger economic picture, the sustainability gains, the impact is even clearer. The paper points to several key metric improvements, like overall equipment effectiveness, OEE. That measures how well manufacturing kit is used, usually 70–80%. AI factories, they're pushing that up to 85–95%. That's a huge jump in efficiency. Or time to market for new products, usually 12–24 months. AI is cutting that down to 6–12 months. Faster innovation, products get to you quicker. And the return on investment, pretty amazing. The paper shows 150–250% annual ROI for these AI projects, paying back in just 3–5 years. These aren't marginal gains, they're fundamental advantages. And beyond the money side, AI is making huge strides in sustainability. That's critical now, right? It does this by constantly watching and predicting energy needs for things like furnaces, chillers, compressors, very energy-hungry systems. AI adjusts settings dynamically in real time, learning the best patterns to cut waste. Way better than static schedules. This leads to about a 30% reduction in energy use per unit made. That's substantial. Plus, AI-controlled recycling. Think advanced vision and robotics sorting materials super precisely. This pushes scrap reuse rates over 90%. It's genuinely supporting the idea of zero-waste factories, minimizing environmental impact.
So what's the takeaway for you listening? Whether you're a consumer, an investor working in the industry, or just curious, it means the stuff you buy could be more innovative, maybe cheaper, arrive faster, and be made with a much lighter touch on the planet. Sounds like a win for the economy, for you, and definitely for the environment.
But okay, with all this potential, there have to be challenges. Which raises the question, what are the roadblocks companies hit when adopting AI, and how are the successful ones getting past them?
You're absolutely right. It's definitely not all smooth sailing. A big one that paper flags is workforce resistance. People worry about losing their jobs to automation. That's a real, understandable fear. So the best way to handle it seems to be open communication. Making it clear AI is often about helping people, not just replacing them, pairing that with solid reskilling programs, helping employees learn new skills for these changing roles, and deliberately designing jobs around human-AI teamwork. It's about empowering the workforce, giving them new tools, creating new kinds of jobs. Then you've got critical regulatory and operational concerns. When AI makes decisions, especially with safety involved, who's liable? How do you validate the system? The paper suggests using those explainable AI tools, XAI we talked about, for transparency. Also, keeping a human in the loop for high-risk decisions. Human oversight is still key. And importantly, following emerging standards like ISO IEC 42001, that provides a framework for managing AI responsibly. And finally, you can't ignore data quality and cybersecurity. Bad data, inaccurate, incomplete leads to bad AI models. Unreliable. And every connected device, every sensor, every AI system is a potential security risk and attack vector. So mitigation means strong data governance, making sure the data going in is clean and reliable. Automated checks help there. And on security, things like zero trust network architectures, basically. Trust nothing, verify everything, plus regular security testing to find weak spots.
Right. So these aren't necessarily showstoppers, but definitely things that need careful thought and planning. It sounds like the successful companies aren't just throwing tech at the wall. They're being really systematic about how they implement it and thinking about the wider impact.
Exactly. And the white paper actually offers some really practical advice for leaders navigating this. First, start small, win big. Don't try to overhaul everything at once. Begin with projects that have high impact but lower complexity. Things like visual inspection, predictive maintenance on a few key machines, maybe optimizing demand forecasts. Get those quick, measurable wins. That builds confidence, shows the ROI, and gets people on board for more. Second, absolutely critical, foundation first. You just can't build a smart factory on bad data infrastructure. That means serious investment in robust data systems, unified data lakes to bring everything together, standardized data streams using protocols like OPC UA or MT Connect. Think of them as universal translators so different machines can talk to each other, and good metadata so you know what the data means. The solid data groundwork is non-negotiable for AI to work well. Third, reinforce that human-in-the-loop idea, like we said with XAI and safety. Prioritize explainability. Make sure humans can oversee and step in, especially where safety is critical. It builds trust, ensures accountability, uses the best of both human and AI smarts. And finally, skill up. Companies need solid plans to reskill their current workforce. Not just basic training, but building whole new types of jobs right there in the factory. Think AI ops engineers managing the AI systems, digital twin managers looking after those virtual copies, human AI collaboration specialists. Investing in these skills is vital for the long haul, making sure people evolve alongside the technology.
Okay, so it's definitely not about diving in headfirst without a plan. It's a strategic, step-by-step approach. Build capability, build confidence, keep the human elements central, get the foundations right. Sounds like a sensible roadmap for what's clearly going to be a huge shift in industry. So as we wrap up this deep dive, what's the big picture takeaway for you, our listener?
The core message is pretty undeniable, I think. AI is set to become the fundamental operating system for the next generation of factories. It's not just another tool, it's intelligence being embedded into every function: design, planning, production, quality, the supply chain, everything. And that's what unlocks these incredible levels of efficiency, agility, and sustainability that just weren't possible before. And maybe to leave you with a final thought, something really forward-looking from the paper. Imagine truly self-optimizing factories, where reinforcement learning agents are autonomously tweaking processes, schedules, logistics, all across a global network, reacting instantly to events without a human needing to step in directly. Or think about human-centric AI. Maybe brain-computer interfaces, BCIs, or AI that senses emotion, adapting a workstation to how an operator is feeling, maximizing their comfort and focus, reducing fatigue. This isn't science fiction anymore. It's the direction things are heading, driven by the very tech we've discussed. Factories becoming smarter, yes, but also maybe more attuned to both the product and the people making it.
That is a powerful vision. Really underscores how deeply AI is going to weave itself into our industrial world, changing not just the machines, but the very nature of work. So I'd encourage you to think about what this deep dive means, not just for manufacturing, but for all the industries you interact with, maybe even your own career path. Because adopting AI strategically today, that looks like the key to gaining a decisive competitive edge in the incredibly fast-moving markets of the 2030s and beyond.
Until next time.
Keep exploring, keep questioning, and keep diving deep.
Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.